today we will try to solve the problem related to types of natural selection. Okay, so here is the problem. The body weight of adult female of a strain of Drosophila is 1.8 plus or minus 0.45 mg. So in lab experiment, each of the three groups, that is denotes as A, B and C, of this strain was subjected to a different type of selection pressure, having an influence on the female body weight. So after many generations of experimental selection pressure, the body weight changes. So for group A, the body weight distribution will be normal, that is 1.8 plus minus 0.08 milligram, and for group B, body weight distribution will be bimodal, 1.4 plus minus 2.2 mg, and for group C it will be normal distribution, and that is 2.2 plus minus 0.08. So before starting to explanation of this problem, I suggest you to have a clear-cut understanding of types of natural selection. Okay, if you have a clear-cut understanding about the theory of types of natural selection, then and then you will be able to understand the explanation of this problem. So here what they suggest is that before selection pressure, that means before natural selection, body weight was 0.45 mg. So the standard deviation, the mean value is 1.8. Okay, and now after selection pressure, for many generation of Drosophila will pass, and the body weight changes, and three different weights in group A, B and C are taken. Okay, that is 0.08 milligram, 2.2 milligram and 0.45 milligram. So here in the group A, after selection pressure, it will be 1.8 plus minus 0.08 milligram, and before selection pressure it will be 1.8 plus minus 0.45 mg. So for this value, we can clearly understand that there will be no change in mean value. Okay, so it means Drosophila fruit fly of 0.08 milligram body weight is favored after selection pressure, and there will be no change in the mean value. So if we plot a graph of these values, then before natural selection, the graph will be look like normal distribution, and Drosophila fruit fly of 0.45 milligram weight was favored, and at this time mean value was 1.8. Okay, and after selection pressure, Drosophila fruit fly of 0.08 milligram is favored, whereas 0.45 and 2.2 milligram body weight fruit fly is not favored. So and in this value again mean is unchanged, that is 1.8. Okay, so from this distribution we can clearly understand that such kind of a selection is directional selection. Okay, and whereas in group 3, after selection pressure, mean value is 1.4 and 2.2 milligram body weight is favored, whereas before selection pressure, mean value was 1.8. So after selection pressure, mean value decreases, and 2.2 milligram body weight fruit fly is favored, and that is bimodal distribution. In that, two other extremities of different weights are picked as an end value, and 2.2 milligram body weight is favored, and mean value at this body weight is decreasing, and such kind of distribution is disruptive selection. Okay, and now whereas in group C, after selection pressure mean value is 2.2, and before selection pressure mean value is 1.8. So it mean value is increasing after natural selection, and distribution is again normal, but 0.45 milligram body weight is favored before selection pressure, whereas in after selection pressure 0.08 milligram body weight is favored. So if we plot a graph, it will